My dear students, today actually we are basically going to discuss that force and pressure. Okay, this will be the first lecture. And in the force, basically we are going to discuss what is inertia, what is that one velocity, what is momentum, then what is the definition of force and what are the types of force. Okay, we are basically, I think we will cover all these things in today's class. So let us see. Okay. So the name of the chapter is force and pressure, and I hope you will just keep just prepare your notes also. I'll give some the definitions also. And myself is Mr. Amarnath. So whenever any doubt arises, so feel free to ask me. Okay, it is a very open class. You can ask me anything. Okay, and our that
Yeah.
strategy of our discussions will be actually uh, so that we can even try for that Olympiad like exam also in future. Okay, so we will try to build up a foundation on it. Okay, that is the thing actually. So sometimes, okay, any issue, Shikha?
Yes, sir. Actually, can you kindly send today's link on my other for my mobile number?
Okay, shit.
Thanks a lot, sir.
Okay. Okay. The out of the two, force and pressure, we are going to discuss in details actually force. Okay, so actually to know force we should understand first inertia and mass and all these things. Okay, we step by step we are going to discuss. Okay, so at the very beginning let me discuss what is inertia. Okay, actually what happens, you see, you understand that say you have an object lying on the table. Okay, say this is the table, it is an object. Okay, unless and until you disturb it, say on the table this is an object. Okay, unless and until you disturb it, you always will be lying on the table only. Okay, because it is the object is at the inertia of rest. Okay, it means the situation of the object is it is at rest, so it always wants to be at the rest only. And similarly, say one object is moving in the space. Okay, one just astronomical object. Okay, say the object is moving in the space. Okay, so it always try to keep on moving in the same direction without changing the velocity, without changing the direction, without changing the speed. Okay, so that is called inertia of motion. Okay, yeah, you can say it is the state. It means actually an object cannot change the state by its own. Okay, that inability is called inertia. Means inertia means inability. Say I am here now, without applying a force, external force. Okay, remember it, external force. I cannot move up, I cannot stand up. As I push down the floor gives me a normal reaction upward. Na? Because of the normal reaction only I able to stand up. If the floor does not offer me that normal force, upward force, I cannot stand up. Okay. Otherwise, you have to pull me up. Okay. You will be the external force then. So it means inability of a body to change its state. That is called inertia. Okay. Say on a very slippery place, a person started sleeping. Okay. So it will keep on sleeping only. It will keep on sleeping only unless and until someone from external, okay, agency just stops it. That may be friction, that may be a wall, or that may be something, someone, some other body. Okay, so that inability is called inertia. You please write down. the inability of an object to change its state of motion or at rest by its own is called inertia. Okay, it is simple definition only. Okay, please write down all these things. Well, now we see. So I hope you understood the inertia. Okay, so now you try to feel it. Okay, say one is small particle and one very large object. Okay, so what do you think? Which one will have the more inertia? That more inability of changing its state by its own? The small particle or the large object? Which one will have more inertia? Okay, what do you think?
Sir, the large object.
That heavy one. Okay, so actually mass is the measure of inertia. Okay, that is a very important definition of mass. More will be the mass means more will be the inertia. Okay, not actually the size. Okay, in some cases size may be more but density is very less, so obviously mass also will be less, then inertia also be less, na? Because a large balloon can be pushed up directly by you, na? But if the size of iron is of the size of balloon, that will you be able to that push the iron ball of the size of balloon? No, both are having the same size, but mass of the iron is very large. Okay, it has more inertia. Okay, so I think now did you write all these things, the definition of inertia?
Yes, sir.
Okay, now you please write down actually mass. Okay, mass. So what is mass? That simply you can write the mass is the measure of inertia. Mass is the measure of inertia. More will be the mass, more will be the. Normally, we say that mass is the amount of matter contained in a body. Okay, that is also correct, but it is better definition. Okay, it is the better definition. Mass is the measure of inertia. It is also the matter contained. Adjuta, my accent is a little bit different. Are you comfortable with it? Are you getting
Yes.
whatever? Okay, okay, with that. Okay, okay. It is also if you find any problem, just let me know. Okay, I will definitely. It is also matter contained by a body. Okay, so SI unit of mass is kg. Okay, you should know some other units also. Gram, quintal, ton. These are some other units. Okay. Other units, gram, ton, okay, milligram also, okay. quintal also. Etc. Okay. And remember, there are basically two type of quantity. One is scalar quantity, one is vector quantity. Okay. I'll give the details in later classes. Okay. And mass comes in the scalar group. Okay. So you should remember it. So something actually, being a kid, na, you should learn also something. Na. Everything cannot be actually explained in in a single class, because you see some concepts are there in class 9 also. Okay. So, but the term will be used in class 8. So in that cases, if you find, if I say that learn it, just you should learn it also. Okay. Uh, that mass comes in the category of scalar quantity. Okay. It is a scalar quantity. Means in case of vector quantity, na, direction is very, very important. But in which direction the vector is going. But scalar quantity, direction is not much important. Okay. Direction may or may not be there, no issue. But it is not necessary actually. Okay. That is the thing. So for the timing, you should understand. So you got it. What is the unit? What is the SI unit? Okay. What is the scalar quantity? Like this. Okay. Now you just copy it.
Done, sir.
Okay. Great. Great.
Excuse me, sir.
Okay.
Sir, what does scalar quantity mean? I did not get it properly.
Which one?
Scalar quantity.
What is scalar quantity? Na?
Yes, sir.
Okay. Okay. Actually, you see, first of all, you should understand what is physical quantity. Okay. Physical quantity. Actually, any quantity that can be measured are called physical quantity. Okay. Like length, time, mass, temperature, all can be measured are called physical quantity. But physical quantity is of two types. One is scalar quantity. Okay. And another is vector quantity. Okay.
Yes, sir.
So in scalar quantity, actually, you see, say 5 kg, na, 5 kg, say 5 kg, 5 kg. That 5 is called numerical value. It is also called magnitude. Magnitude, okay, magnitude. And this is called unit, okay. This is called unit. Means if a quantity can be expressed by magnitude and unit, then it is called scalar quantity, okay. Example, mass, time, etc. Okay, I'm not going to discuss in details now. But in case of vector, actually, say velocity is a vector, na? Say 10 meter per second towards east. Okay, so 10 is the magnitude, means numerical value. Meter per second is the unit, and this is called direction. Okay, so for vector quantity, we must need magnitude also, must unit also, must direction also. Okay, but in case of this scalar quantity, direction may or may not be there. Like electric current has direction, but it is a scalar quantity. Okay, and one more thing, one more vector quantities property is there, that it follow a different algebra actually, that is called vector algebra. Okay, that is called vector algebra. What is algebra? I am going to just, these will not come in your chapter. Okay, this is not required for you for the timing, but just you write down vector algebra is what is normal algebra is, in normal algebra actually 2 plus 2 is always 4. Okay, but in vector
Yes, sir.
algebra 2 plus 2 can be 0 also and 4 also, and in between 2 and 4 anything it can be. How I am going to explain, say say this is an object. Okay, I am applying a force 2 Newton. SI unit of force is Newton. Okay, today only I am going to write it. So this is also 2 Newton. So altogether it will be 4 Newton. But if I change the direction, say this is 2 Newton, this is 2 Newton. Now the result will be 0 Newton only. Okay. In here it is 4 Newton, but here it is 0 Newton only. Means depending upon in which direction you are applying the that one vector, okay, the result changes. So this is called, actually this type of calculation is called vector algebra. But in normal algebra 2 plus 2 is always 4. But in vector algebra, two vectors, actually we should not write like that. Say f1 vector plus f2 vector value may be from 0 to 4. It can take any value. Even it can take 1 also, depending upon all. Even it can take 2 root 2 also. Okay, depending upon the direction of application of force. If I apply the force in this direction, okay, say at some 90 degree, so the resultant will be something like this. Okay, not require all these things now. Okay, just you have asked me, that is why I told you. Okay, and if you want to write the example, you can write just two example. Example is force. Example is velocity. Example is the momentum. But what is momentum? Up till now, you don't know. We are going to discuss nothing else. Momentum. Please write all these things. If done, just let me know.
Sir,
Over.
excuse me, sir. Sir, I wanted to ask one thing. So, sir, you gave an example of 2 plus 2 is equal to 4. So, the maximum quantity it can get is 4. But if we take 3 plus 2, it can take maximum quantity as 5 only. Like
5
this.
and 1 and 5. Minimum 1, maximum 5. Okay.
It could 2 and 3 can't take a quantity of 0 also. 2 plus 3.
No, it cannot. It cannot be. Okay. It cannot
Why,
be.
sir?
See, if it is 3, if it is 2, okay. So I get the maximum value when the direction of force, direction of vector is same. Okay. Say it is 2, it is 3. So then direction equal to, it will be equal to 5. Okay. And if it is 3, but it is 2, okay, then answer will be 1 only. It means the value ranges from a minus b to a plus b, okay, like this.
Okay, sir.
The value ranges from, we have a definite formula, okay, we'll discuss in other classes. We have a definite formula actually, how it is calculated, but now it is not possible today.
Sir, but you wrote 2 minus.
Plus, okay, from minus to plus. Okay, so if I say, you say 2 and 5, okay, what will be the minimum value? It will be 3. Okay, what will be the maximum value? It will be 8. Nah? So it can take any value between this vector algebra, according to vector algebra. So in vector 2 plus 5, in vector 2 plus 5 may be 3 also, 4 also, 5 also, up to 8, anything. Even 3.3 also, 3.332 also, could be anything, it can be. But it cannot be 2. It cannot be 9 also. Understood, na? In vector. But in normal algebra, 2 plus 5 is always 7.
7.
Okay. Okay. Now, what is velocity? Okay, you see. Say this is a point, okay. From this is your home. Through this zigzag path, you go to your school, okay. So actually, the actual path is called distance, okay. Actual path is called distance. But the shortest path, this is called displacement, okay. And velocity is nothing but rate of change of displacement, okay. So what is velocity? The rate of change of displacement is called velocity. It means V equal to displacement by time, you can say. Okay? Not distance, huh? Displacement by time. Again, displacement is vector quantity. Vector velocity also vector quantity. SI unit of velocity is meter per second. Okay, that is meter. S will be in meter. Time will be in second. It is a vector quantity. Huh? You should remember all these things actually. Yeah? If I say y force is a vector, okay. But if I say force is a vector, you immediately try to learn it. Okay, I can explain it, but we have large number of quantities now. How can I explain all each and every one? Okay, what is the requirement also? Okay, automatically you'll get the feel also in the higher classes. It's a vector quantity. Okay, displacement is a vector. Okay, but distance is scalar. Huh? This is scalar. Displacement is vector. Displacement has a definite direction from A to B, but distance has no any definite direction. It can be anything. Huh? That is why.
So distance does not have any direction.
No, not no, you cannot say does not have any direction. Okay, that is a wrong word. Does not have any definite direction. Okay, that is the thing. Okay. Distance does not have any definite direction. Okay.
It can have a direction, but not definite.
It is small segments. No? I'm going from here to here, here to here, here to here, every time. Okay. Actually, meaning same only. Okay, it does not have any definite direction. So, and you are saying that it has the direction, but not definite. Both are having the same meaning only. Okay. So it
Okay,
is.
so
So if somebody says you, if the distance has direction, no, you'll say no. Okay. Because it has no any definite. If it is not definite, then how can we accept it like this? Okay. Distance has no direction. You can say like this. Okay. If somebody asks you, does distance has direction? No, you'll say no. You'll say. Anyway, I hope you understood what is velocity. Velocity means what? You see, simply say from your home, you have taken to your school total time, say 1 hour, okay? And the displacement is say 10 kilometer, okay? 10 kilometer. So what will be the velocity? It is nothing but 10 by 1, which is equal to 10 kilometer per hour. That's enough. So from velocity, you will understand how fast you can reach a target. Okay, but that is our not aim today. Our aim is force only. Okay, I'm going to that part only. Okay, can I rub all these things?
Yes, sir.
Momentum. What is momentum? Momentum actually what happens? Already I have told you what is mass. No? It is that one inertia, measure of inertia. And say this is a particle, it has mass say m, and it is going with velocity say v. Okay, so you know what is velocity, rate of change of displacement. You know what is mass, okay, amount of matter by the contained by the body, or you can say it is the inertia. Okay, then what is the product of mass and velocity? Okay, it gives the strength of a moving particle. Okay, so that is called actually momentum. So what is momentum? It is the product of mass and velocity of an object. Achha, momentum symbol is P, velocity of an object. Adrita, if the meeting gets over, okay, you will click the same link and join the meeting back, okay? Clicking the same link only.
Okay, sir.
Class will continue up to 8 o'clock, okay? So symbol of momentum is P, and already by definition it is product of mass and velocity. So m into v, okay? And one more thing, we should know that m is scalar, but v is vector, na? So momentum also will be a vector only. Okay. Momentum is a vector quantity. Okay. Actually, what momentum physically says you, it is the strength of a moving particle, okay, moving object. It signifies, yeah, you can say that it gives the idea, okay. Momentum gives the idea of strength of a moving object, okay. I can say, you see, sometimes you see, if mass is also more, velocity also more, so obviously momentum will be more, okay. If mass is also less, velocity also less, then obviously momentum will be less, okay. But in some cases, mass is less, but velocity is very, very tremendous, then also momentum may be tremendous. Like the bullet from the gun. The bullet mass is very small, no? But its velocity is very tremendous. So that is why strength of a bullet is very tremendous. So it can that one penetrate a wall also or hard object also. Okay, this is the momentum strength. And train is coming very slowly. Say, so velocity is very slow, very less during that one halting in a station. Okay, the train is coming very slowly, but mass is very tremendous. So then also momentum is very tremendous. You cannot stop the train by pushing it, okay? Because it has large strength, very large strength. Though the velocity is very less, but mass is very, very high, and hence momentum becomes very high, okay? So it means momentum not only depends on mass, but also velocity, both, okay? Momentum has no any specific unit, okay? So it can be derived by, as the mass is kg, as it is meter per second, so it means SI unit of momentum is kg meter per second, okay? And one more unit is there, that is called Newton second, but we will get about this little later only, okay? Just you write down now. Other unit is Newton second. Both are SI, huh? This is also SI unit. This is also SI unit. SI, you understand, na? Is internationally accepted unit. Okay, system international. It is accepted everywhere. Okay. I told you actually my class.
Newton.
Pardon? Newton. Newton. Newton second. But how it comes?
Sir, Newton is the
No,
unit by which we measure
no. It is
force.
not minus actually. It is a way of writing. Okay. Newton second.
No, sir.
It is
Sir,
not minus.
Newton. Sir, Newton is the force.
Uh,
It is the unit by which we measure force.
It is Newton second. What you told me, just repeat it.
Newton is the unit by which we measure force.
Yes, obviously. We are going to discuss about it. Then,
Sir, this is the question.
just we are going to just you write down only. Okay, I'm going to discuss this thing only now. Just you write down Newton second, Newton dash second. Okay, it is not minus. Newton dash second. and momentum is a vector quantity. Okay, you please write down. Very important. Momentum is a vector quantity. Actually, the main vector quantities characterize that if one quantity is this way, say this is 2 Newton force, and another force is say this way, you cannot write like this. You have to write minus. If one direction is positive, the other direction will be definitely negative. Okay, it is strictly must be followed in vector. Okay. Anyway, so I hope up till now you understood all these things, and we can have lot of questions. We can frame lot of questions or what we have discussed till now. Can I? Okay. Now you see what is change in momentum. Okay, change in momentum. Change in momentum. So change in momentum, it is called del. Del P is always final momentum minus initial momentum. Okay, anything change, always final minus initial. That del is the symbol of that one, change. So if I ask you, a car of a small car, toy car, say, a toy car of mass, say 2 kg, moving with velocity, say 5 meter per second, is accelerated. Accelerated means velocity increase karna. Is accelerated. Accelerated दबा दिया, ठीक है? Accelerated to velocity 10 meter per second in the same direction. So find the change in momentum. Okay, that is my question. So first 1 minute you also think with this formula only. Okay, change in momentum is nothing but final momentum minus initial momentum. Okay, and momentum is nothing but mass into velocity. So please try.
Excuse me, sir.
Okay.
Is it 0?
Nah. You see, the change in momentum. Delta P. Delta means change, okay? Delta P equal to, you see, if you don't write the vector sign also, we'll understand, okay? Delta P equal to final momentum minus initial momentum. Final momentum means mass into final velocity, because mass is same only, na? And initial momentum is mass into initial velocity only. You see, in some cases, now mass may also change. Remember, momentum can be changed by both ways. You can change the mass, or you can change the velocity, or you can change the both. The velocity changing example is I have already given. Okay, this is a beautiful example. You are accelerating your car, so obviously the mass of the car will be remaining same and the speed of the car will increase. It means velocity increases, momentum increases. But you imagine rocket, when the rocket start propelling, na, so it ejects gas, na, fuel goes out. So it means mass of the rocket goes on decreasing. So we have lot of examples where mass also changes. Okay. So you don't think that mass
Yes.
always remain constant. Lot of examples, mass goes on changing. Okay. Okay. In our problem, as I have already that one discussed. So del P is what? That is nothing but final momentum minus initial momentum. And mass into final velocity, mass minus mass into initial velocity. So you can take the mass common also if one, because both are same only. Okay. So if you don't want to take common, then also no problem. The mass was 5 kg and final velocity is 10. Okay. All are in SI. Mass was 5 and the final initial velocity was 5. And it is what? It is 50. That is 50 minus 25. So it means 25. Okay. And already I have told you SI unit is kg meter per second. Okay. That is the answer actually. Okay.
Yes.
Okay. But this, what I am interested to ask you is something different. Okay. Because you see, to calculate force now, we should understand the momentum properly. Eh? So have you copied this thing? Can I move?
Yes, sir.
Okay. Okay. Say, think of a situation. Say, this is a wall. Okay. Wall. A ball of mass 2 kg goes with 10 meter per second, okay, strikes it and then bounce back with velocity, same 2 kg ball, bounce back with velocity 10 meter per second, okay, same speed it bounce back. So what is the momentum? What is the change in momentum of the ball? Okay. If the ball of mass 2 kg bounce back with same speed striking the wall. Calculate the change in momentum. Okay. This is also called the momentum imparted by the wall. Okay. Because the momentum change is given by the wall only. No? Wall has given the you can say na impulse, dhakka. Okay. We say the dhakka. Like cricket bat. Na? Sachin Tendulkar. Ball is coming and hitting by the bat. Okay. The momentum of the ball is changed by the cricket bat. Na? That is called impulse. Okay. The impulse provided by the
Sir,
cricket bat.
sir, the answer is 0.
Answer is 0. See, actually
Yes,
it
sir.
looks like 0, but remember it is not exactly 0. Huh? Why it is not exactly 0? You will understand now. Okay. Because momentum is a vector quantity. Na? If this direction is positive, this direction must be negative. If this direction is positive, this direction must be negative. Okay. Because they are opposite direction. Na? You see. So here del P equal to final momentum minus initial momentum. Momentum is velocity final, velocity initial. Momentum is 2 into velocity final is 10. Okay. Minus mass is scalar. But velocity initial you have to take minus 10. Okay. That is very important. Very, very important. Okay. Because if this direction is positive, opposite direction will be negative. Okay. Even you can do this also negative, but this will be then positive. Okay. If it is not mentioned in the question, so I need only the value, na? That is right. So this is 20 and this is again 20. So this is not 20 minus 20. Okay. 20 minus 20 will be, when it will be 20 minus 20, you see. Say a ball is going with 10 meter per second. Okay. And it strikes some, say, any object. Okay. It strikes, then again it keeps on going only in the same direction with the same velocity. Say it strikes a feeder, okay, and the velocity does not change. Imagine, though it is impossible, but you imagine that velocity does not change. It goes with the same velocity. Momentum will be zero. It means the feeder is not applying any force, not applying any impulse, but this wall is applying any force, okay, large force, impulse, okay. So answer is 40 kg meter per second, okay, that is delta.
Sir, I have a question.
Okay.
Yes, I'm actually saying that if I take the final as the negative, so will it like change the answer?
Change will be negative. Change will be negative, but it will give you direction only. Magnitude will be remaining same. Okay. If you take, you see. Actually, here in the question, it is not given that which direction you need to take positive. Okay. Say I am taking this part negative. Then in this part will be positive. Okay. So answer will be minus 40. So minus 40 or plus 40. The value is same only, na? Minus 40 means direction is leftward. Okay. You are saying, you see that the particle is hitting the wall, then bounce back. So impulse direction is the force given by the wall actually. Okay. I am going to force only. Okay. That is why I have discussed all these things. The wall is giving the dhakka in this direction. Na? So it means leftward. So now it depends. Leftward is positive or negative. In first problem, I have taken leftward is positive. So answer is positive. It means dhakka is, impulse is, force is leftward. In second case, you have taken leftward direction is negative and answer is also negative. It's been in both the cases, the force is leftward only, okay? Say the ball is going and this is the cricket bat and bat is applying a force leftward. Then that is why the ball changes the momentum, okay? So in
Got
that,
it, sir.
don't think that in question in exam, without giving the proper direction in the question, they will ask they will give the option minus 40 also, plus 40 also. No, not possible. Okay, that will be a wrong question. If they ask like this will be a wrong question. Okay, but magnitude in both the cases it is 40 only. Okay. Understood?
Yes, sir.
Okay.
Yes, sir.
Then we come to the last part. Okay. What is force? Now we are coming to that force. Okay. Actually, the agency that which causes that one momentum change. Okay. That is actually the force. It is the external agency which can cause a change in momentum. Okay. The external, it is a push or pull. There is nothing but if I push it, the momentum increases. Okay. Say a stationary body. If I push it, say it is stationary, it means momentum zero. If I push it, it will create some momentum. Say object is going, already going. If I push it, the momentum will decrease. Say the object is going in this direction, but I pull it this way, so it will change the direction. It means momentum will change. Okay, because direction change also momentum change, remember. Because momentum is a vector quantity. If the direction is changing, say moon is revolving around earth. This is earth. Moon is revolving. So all the time momentum of moon is changing because moon has momentum is velocity. So earth is pulling. So this force is changing the momentum. Okay. So the external agency which can cause the change in momentum of an object is called force. Okay? It may be a push or pull. Okay? It may be a push or are you getting? Say this is force I have
Yes,
applied
sir.
here. So its velocity is 0. Now the velocity is something v. Okay? It means momentum is increasing. Okay? Sometimes momentum may be decreased also if I apply the brake friction on the surface. Say this is a rough surface. Okay? This is a rough surface. So this is an object. I have given a impulse. Say velocity is 10 meter per second. Mass is say 2 kg. But after some time, the object will go and stops. So it means momentum change. Who is changing the momentum? The friction. Friction is a force. Okay. So remember, momentum increases, force is required. Momentum decreases, force is required. And momentum changes the direction only, then also force is required. Say one ball with a thread in my hand, I am just like a whirlpool, I'm just rotating it, okay? It means all the time I am pulling the thread towards the center, okay? So the ball is rotating. See, momentum is changing and I am pulling. Electron is revolving about the nucleus. Electron momentum is changing and nucleus is pulling the electron, okay? Moon is revolving about Earth. Momentum is changing because Earth is pulling it. If Earth stops pulling, the moon will escape in a straight line, tangentially, okay? As long as Earth is pulling it, the moon is revolving. If Earth stops pulling, the moon will escape that one, okay? Tangentially, okay? Go out of the orbit. Understood?
Yes, sir.
Okay. Now you write types of force. Oh, sorry. You should write that one also, that one, SI unit of force, okay? You please write down. SI unit of force. I have already defined it, So you write SI unit of force is Newton. That is, I have already told you. Symbol is N. CGS unit force is dyne. Okay, you should remember all these things. Dyne, Newton. And there is a relation also between 1 Newton equal to 10 to the power 5 dyne. We can prove also, okay, but for the timing, you just like you see 1 kg equal to 1000 gram, like this only. 1 kg equal to 1000 gram. It is just by, you can say, definition. So in that 1 Newton equal to 10 to the power 5 dyne also you can learn like that, but we can prove it, okay, how it is, we can prove it. And we'll do it in later case. And remember, force is a vector quantity. Very important. Force is a vector. Okay. Now, basically, force has two types. Okay. Basically, the force has two types of force. One is field force. I will check your copy time to time. Another is contact force. What is field force? Field force means there is no any physical contact. You see, this is the marker. I have pulled it up. It means there is a contact force. There is a physical contact between my finger and this. Say it is that one tied with a thread. Okay, so I pull the thread and thread pulls the marker. Okay, that means tension is a contact force. Normal reaction is a contact force. But what is field force? Gravitational field. If I release it, the earth pull is down, na? Without any physical contact, na? So that is called field force. So example of field force is what? Gravitational force is an example of field force, gravitational force. Can you give me one more example of field force?
Sir, can we say magnetic field?
Magnetic force, electrostatic force, okay?
Yes, sir. Yes, sir.
Electrostatic force. Force between two charge, force between two magnet, force between two mass. Force between two mass is gravitational force. Force between two magnet is magnetic force. Force between two charges, electrostatic force. And contact force is friction. Tension. We are going to discuss all in details, okay? Friction, tension, normal reaction. What are those? We'll discuss, okay? No need to worry about it. Spring force. Okay. So on that note, I wind up today's class, okay? And tomorrow we are going to discuss in details about these forces, okay? Friction, tension, normal reaction, spring force, okay?
So,
Yeah.
will the class happen tomorrow?
No, not tomorrow, actually, in a regular time schedule, okay? I think it will be Monday, Wednesday, okay?
Yeah, after tomorrow.
8 o'clock. Okay, on that note, I want to wind up class today, okay? Thank you. Bye-bye.